Good afternoon. Thank you for coming to this session on OpenRemote. In a moment, I will talk about the details, the technical details of OpenRemote, but I first would like to address the rationale behind the project, why we chose to do it. And to do that, we'll take a brief look at the state of the home automation industry nowadays. So home automation. Basically, we want to control all those things, the lights, the blinds, the heating, home audio, video, stuff like that. And we say home automation, so we think the home, residential market, but clearly the same technology, the same needs apply to hotels, industrial, things like smart metering, tie in nicely with home automation, offices, hospitals, many more. So what do we want to do? We want to control so that when you touch a button on your touch panel, your lights goes on, stuff like that. But we also would like to automate so that based on, for instance, a temperature or a time, we can trigger some events based on rules, stuff like that. To implement that, we want a platform that will connect to all those devices that we need to control. The devices, the actuators, the sensors. We want a place where we will run the logic, so the automation part, and we want to use to have user interaction, so interfacing to touch panel, keypads, or Twitter feed, anything. So looking at the industry, we see that we have a few problems to overcome to implement this. The first one is the protocol. So all the devices that we want to control, most of the time they have different protocols. And worth, those protocols are often proprietary, so it's very difficult to get the information on how to control them. There are some standards in the home automation, but still there is fragmentation. So you have many different flavors of standard to care about, so still big and complex. Quickly on the cost, the hardware used for home automation is pretty expensive. For instance, if you look at the touch panels that you can embed in the walls, it goes for a few thousands euros. So it's that is for specialized material. And the distribution is also pretty high-end, so expensive, again, difficult to find. We want to get rid of that. So what do we propose? Our solution is to first go with open source, of course. This means that on the software side, at least, we can reduce the cost to zero. It also means that this big problem that we have of having so many different protocols, if we address that as a community instead of as a specific company, we have a much better chance to cover those different things. What else? Well, we want a standard, but not a proprietary one. We want an open standard, a de facto standard that will be totally open. We publish all APIs and all the XML or JSON format that we use on the website. And it's been proven in the past that an open standard, it's a better value proposition than a proprietary one. Last thing, we want to use off-the-shelf hardware. So we said the cost of software is now going to zero. We want the cost of hardware to go, not to zero, of course, but as low as possible. We're quite lucky because we nowadays have a lot of devices that can be used for home automation and that are not that expensive. So that's basically it, what we want to cover. Open source, an open standard, and off-the-shelf hardware. Let's now take a look at what we've done. This is the global view of OpenRemote. The bottom part of the diagram is your private LAN. The top part is the internet. The central piece is the OpenRemote controller, or the orb. That is the main runtime component. Connected to that, we'll have the consoles, so the user interface, that can run on your LAN or on your WAN. So you can have that access from the internet. In that case, for non-technical people, we have a component called the remote proxy. It just makes connection from the internet easier without the need to set up VPN or NAT or stuff that usual end users are not familiar with. Then we have a tool to configure the system, which is the designer, and its counterpart which is Beehive, which is basically a database. We'll talk about all those components in more details now. So the controller, it is of course the central brain of the system. It's the runtime component running 24/7. It is where logic will be running. It needs to talk to the different devices, so it does talk those different protocols, all those proprietary protocols or open ones. It knows about them. It has been implemented, or it is implemented as a Java SE application. So the goal is to be as lightweight as possible. It's not running on Arduino, but still, we want to run it on off-the-shelf hardware. So for the moment, we've run it on, of course, laptops, but also NAS devices, so Synology or ReadyNAS kind of machines, plug computers, and we are pretty excited about the Raspberry Pi, which is really an inexpensive hardware that's coming soon. As far as protocol goes, we already are covering quite a bit of those. So the main names in the automation industry like KNX, Lutron, X10, we have Z-Wave. We also have some more generic one like plain TCP or HTTP, so that some devices can, if they don't have specific protocols for them, can still be controlled. So next, the panels. The panels are what are rendering your user interface. So they are using an XML description of a user interface and will render it for you. It controls the orb so that the user, when the user touches a button on the panel, it will send a command to the orb, which will eventually control the device. And it also receives information back from the orb. So when the user goes on the wall and switches on the light with the switch, of course, there is feedback going on, going back to the user interfaces. For the moment, what we have is an Android-specific client, an iOS one, a rich web interface, but it's open. So we are using a REST API over HTTP to communicate between the consoles and the orb. The API is public and it's available on the website. It's documented there, and the payload format also. So those were the components that are used at runtime. We now have components that are used at design time. So the designer it's a web-based tool that allows you to basically configure the whole system. It's run on the cloud, meaning if you go to openremote.org, you can sign up freely for an account. But the source code is also available freely, so if you prefer to run it locally on your private cloud, whatever, you can do that. It defines the configuration for the whole system, so everything we've talked about, the devices and the UI, but we still maintain a clean separation between the two. This is an example of defining a device and commands. So we can see here that we define a command. It can be read or write. The command, we define the protocol it is using and the properties, the attributes that are specific to that protocol. Then we also can define a sensor. A sensor as a read command, and it's basically a read-only property for the system. So is my light on or off? What's the value of the dimmer? Stuff like that. Yet a higher abstraction, for instance, here we define a switch. So the switch will combine both the sensor to know the state of the light and the on and the off command, so that you can change the state of the switch. And this becomes very handy when you go to the designer. So in the designer, you have the standard culprit as far as widget goes. So button labels, images, embedding web information, sliders or switch. And so when you define a switch in the UI, what you will do is link to that abstraction we created. So that if you define multiple switches for the same lights, you don't have each time to link to on, off command and stuff like that. On the tech side, it's not implemented as Java SE, but it's a full-blown enterprise application, so using Hibernate, Spring, and all the stuff, because it's meant to run on the server side. It stores information in the database, but still all the configurations of the system can be exported in XML, and that's basically what the designer and, the controller and the consoles used. It's based on XML. And it uses Beehive as its database. So what is Beehive? It is a service and storage repository. It means that this is where all the information, all your designs get stored. But it's also a repository for existing information like predefined templates, graphics, IR code database, stuff like that. Again, cloud-based, again available on openremote.org, but again, open source, so you can install locally. Usually access with the designer as a front end, but again, REST API available. So if you do not like our designer, you're free to have your own, or if you want to script the creation of the configuration of your system, that's one way to do it. Okay, let's take a quick look at what will happen at runtime. So when you define a command, we've seen you define the protocol that is used. In the XML that we generate, you will find that same information. Same goes for the attributes. They go back to the XML. We add an ID so that we can cross-reference things. For the UI, the same thing. We will define a button. We have an ID for cross-referencing. In the designer, we define that linked to that button, there is a command light on. However, in the XML, we don't directly link that command. We just say, if you press that button, something needs to happen. There is a control command. What happens? Well, there is a REST call going back to the controller. Inside that REST call, you have the ID of the button. When the controller gets that ID, he can look it up in the XML and now look the IDs of the commands that it will need to execute in order to have that action happen. So when the REST calls goes into the controller, this is the full sequence of what happens. What is important to note is that basically there is logic that will create the button based on the XML, that this button has a list of classes of instances implementing the executable command protocol, and this is the way the commands will get triggered. That was for command execution. For sensor, that's the overall picture. So on the right there, you have the sensors that can get their value either by polling, either by asynchronously by listening on the network, for instance. When they get information, they push it into the status cache. On the left side are the consoles. So the consoles will, using HTTP server push, get the status from the status cache. What is important to note here is that those two parts are independent. The status cache in the middle will do that. It brings us two different things, which are pretty important. The first thing is that the timing between the way we receive a status update from the devices and the timing between the way the user interfaces update the statuses is independent. The second thing is that we wanted to implement control logic in addition to pure remote control, and we do that by having the status cache there push any changes to event processor. So we have a chain of event processor that can evaluate rules or that can evaluate scripts, so that we can have logic running without any UI connected. So if you want to implement the protocol, basically you need to provide three classes, I would say. A command builder that, based on the XML, will be able to instantiate an executable command class, and also an event listener implementation so that you can read the status, the feedback from the devices. So that was the technical overview. The other key aspect, of course, of open source, as I briefly touched upon, is the community. It's a great platform for hobbyists. It's free. It runs with cheap hardware. We have quite an active open source community. So there is the OpenRemote.org website, forums over there, quite active. And interestingly enough, we also have professionals for the home automation and AV market that are joining on the forum. So we have a good feedback on what happens in the real world, I would say, not just hacking stuff around. So that is it. Thanks a lot for your talk. Clearly, this was a really short introduction. I hope to have another meeting in Belgium in a few weeks, and I will post details on the website. So if you look up the forum, you can see that. So until before the timer rings, I will just run a small video of what some of the users have reported to us and have done with the system. So that's just testing IR control of a Mac iTunes using an iPhone interface. Some tests again of having information about sunset, sunrise, daylight changing, stuff like that. Okay, so thanks a lot. You can see the rest of the video online.